Hello, friends. Welcome to Block Bytes. A lot of buzz is going around the world of zero knowledge scaling, with frequent tweets from different projects claiming to start their own zkEVM. But what is a zkEVM and why is it important for Ethereum? Let's find out in this video. Ethereum is the most widely used and the most popular blockchain at the moment. This widespread adoption, however, comes at a price. As the number of users and applications increase on the network, so does the transaction count and the transaction fee. The Ethereum mainnet can only execute 15 transactions per second in its present condition. With such constraints, the network becomes overloaded, resulting in slower transactions, higher transaction fees, and the network becoming useless for those who cannot pay. Hence, there is an urgent need to scale the network up, but without harming its decentralization and security. There are different ways in which Ethereum can be scaled up. One way is for the network to itself split into smaller pieces to create mini chains, each with the same capacity, effectively increasing the overall capacity it can handle. This is called sharding and is a form of on-chain scaling. The plan to implement sharding is already part of Ethereum's roadmap. Second way is to create separate blockchains on top of Ethereum, specifically designed to take away the transaction load. These blockchains are termed as Layer 2 chains and are an off-chain scaling solution. Layer 2s roll up or bundle together hundreds of individual transactions into one, and then send that one transaction to Ethereum, decreasing the transaction processing load from Ethereum. Two types of rollups exist today, optimistic and zero knowledge, and the difference lies in how these bundles are sent to Ethereum. Optimistic uses something called fraud proof to check the validity of the transactions once in 7 days, whereas zero knowledge rollups submit a validity proof along with all the bundles to Ethereum. Both have pros and cons. However, within the Ethereum ecosystem, there is a growing belief that zk rollup technology will overtake optimistic in the future. The biggest bottleneck for current zk rollups is something called a lack of EVM equivalence. This is where things starts to get interesting. Let's start by understanding what is an EVM. EVM stands for Ethereum Virtual Machine and is at the heart of the Ethereum blockchain. The need for having an EVM arose because, unlike Bitcoin, Ethereum is much more than just a distributed ledger, as it supports not only user but applications which interact with each other and with the users. The EVM is like a processor which gets input from all these different apps and users, which it then processes into actual changes onto the blockchain. Just like applications and users, zk layer 2s must also go through this EVM. There is, however, one big difference. Unlike the apps and users which are on the Ethereum network, layer 2s are a different chain. So there is a need of a translator between the two. And so what most zk layer 2s did was to build their own translator. This translator would translate the zk proof into a language that the EVM understood. But this has added another layer of complexity to the rollups. The process of application creation and deployment has become complicated giving rise to the need of EVM equivalency. EVM equivalency simply means getting as close to the Ethereum's own language as possible so that the need for a separate translator is eliminated. This is not a simple problem to solve. As a matter of fact, Vitalik Buterin, in his blog titled "The Different Types of zkEVMs," present 5 different versions of EVMs, EVM equivalence, depending on a trade-off between compatibility with the EVM and its performance. And this is how different projects are working on implementing zkEVMs. Polygon, Hermes, Scroll, and Consensys are what is called byte code level EVM, which means that these closely resemble Ethereum's EVM more than the others. A recent tweet by the Polygon ZK team said that they have achieved a 99.5% EVM equivalence now. So what are the advantages of using a zkEVM? What a zkEVM does is it takes all the transaction executed on layer 2s and create an EVM compatible proof, which it then adds to the EVM in as a single line for the bundle. Since there is now an inbuilt compatibility, applications deployed on Ethereum can be moved as is with negligible changes. This is very important advantage, as earlier applications would have to be modified before moving to layer 2s, which would take precious time and effort. And for the end users, they get to use their favorite applications, but with much lower gas fee. Another advantage is that the development of new applications is much easier, since the same tools like MetaMask, Infura, and Truffle used to develop applications for Ethereum can also be used on layer 2s as well. One question that arises is that how does one choose which type of EVM implementation is better or worse amongst the 5? According to Vitalik, there is no better or worse implementation, and that it is healthy for the space to explore all the 5 types. It is possible that over time, with more development and research, one implementation could move from a lower number to a higher number, or the other way around. But he hopes that over time, everything will become type 1. In the meantime, be ready for more announcements from these projects. I hope you like this video. Relevant links are in the description. Consider liking and sharing, and I will see you later with another fresh bite. Bye-bye.